Okay, guys, so in chapter number 4, we here will learn how to collect our data. Okay, actually, the method of collecting the data, it's not easy because you wanted to have a sample from the population that represents the entire population correctly. Okay, we don't need any bias when we collect our sample. Okay, because of course, as I said to you, we need to study the population. This is our target, to study the population, not the sample. But because the population is so huge, sometimes we cannot measure everything. So you have to take a sample from the population. So this sample must be represent the population so we can generalize what we find from the sample to the population. So in this chapter, you will learn some methods of collecting the data, but first we will talk about the type of studies. The type of study. Actually, we have two types of studies, experimental and observational studies. What is the difference between them? So the experiment, what is the experiment in general? Of course, any researcher can do an experiment, right? So what is the experiment? You have subjects, you assign them to expose to some conditions and start to observe what the outcome, right? This is what we all researchers do. So these conditions, the experimental conditions, sometimes we call them treatments. Treatments. And in most cases, these treatments are the independent variable or the explanatory variable. Okay? And the outcome, what we observe, is what the response variable. The observational study. In this type of study, the researcher just observes what is going on. In this study, the researcher cannot assign the subjects to any condition. Okay? Just to observe what is going on and start to take notes or measure what is going on based on the observation. So, for example, I need for someone give me an example um, for a study just to observe what's going on. Like what? I can give you example and you can mimic my example. For example, suppose we wanted to know if the drivers uh, follow the stop sign rule. So in this case, you can go to any intersection has for 3 or 4 stop signs, right? And you will do what? Observe. You will just observe. If this driver, the first one come follow the rule and he stopped at the stop sign or not, and write your what you see, something like that. You cannot tell the drivers stop or not stop. You cannot force them. Okay? You cannot force them. You just observe what's going on. So this is a type of observational study. We have here an example. You can also read about the example in the book in details, but here just the headline. So this study is about what? Student drug testing not effective in reducing drug use. This was in a news released from the University of Michigan. In this study, we had 76,000 students nationwide. They came from 497 high schools and 225 middle schools. Schools selected for the study including schools that tested for drugs and the schools that didn't test for drugs. Okay, so we collect the students from the schools, whatever the schools make the test or doesn't make it. Each student filled out a questionnaire, asked about his or her drug use. And we have this data. Okay? So as you can see, we have here two variables, the drug tests and the drug use. Okay? Of course, the drug tests come from what? From the school, right? The school do the test or the school doesn't do the test. Okay? So we have yes or no. The drug use, this comes from what? The questionnaire. The student will tell us if it's yes or no use the drug. So we have these numbers are the number of students. For example, this is the number of students who use drugs and the school make the test. Here, this number, as you can see, this one. If you calculate the percentage for the drug tests for yes, drug use, I mean, you will divide this number by the total here. You will have the percentage of students use drugs and they tested with, and the test for their drug is positive. Okay, and if it's no, which means the school doesn't make the test for the drug use. Okay, so this is the number of students here divided by the total. So we will find this percentage. You will find the percentage for the first group about 37. So say this is the B1, and for the second group, the percentage here is also 0.37. Okay, and you can see this in this chart. So what that means, regardless the school does the test or not, we have the same percentage of what of drug use. So what that means, there is no association between the drug test and the drug use. But if you have different percentage, that means we have association between them. Okay, so because these two percentage are equal or close to each other, okay, that means no association between the drug test and the drug use. Okay. So the question now, the first question is, what is the type of study? Is it experimental or observational? Yes, it's observational. Why? Because the researcher doesn't make or expose the subjects, the students, to any conditions, right? We just observe if the student does the test or not. We ask the student, do you use drugs or not? Okay, that's it. So we just observe that. How can we convert it to the other type of study? Because we said this one is observational. Okay, how we can convert it to experimental? If you would like to do that, you will do it. Okay, so let's see the answers again. In order for it to be an experiment, the researcher would have assigned each school to use or not use drug testing, rather than leaving this decision to the school. Because this, in case, it will be experimental, not observational. Okay. Another question. What is the response and explanatory variables in this study? So the use of drug is what? is a response variable. Okay, and the explanatory variable is what? Huh? The drug test. Hmm. So as you can see here, to study or the study compared the percentage of students who used drugs in school that tested for drugs and in school that didn't test for drugs. So whether the student used drugs or not, okay, was the response variable. Okay, and the explanatory variable is what the student's school tested for drugs. Yes, explanatory means independent. Explanatory independent variable. Response dependent variable. Okay. Okay. So there is some advantages for the experiment over the observational studies. What are these uh, advantages? First of all, in the observational study, we have something called lyric variables. Do you mean by lyric? Hidden, hidden variables. Lyric means hidden variables. Okay, can affect the results. By contrast, in the experiment, reduce the potential of or for logic variables to affect the results. Why? Because in the experimental design, you already know most of the variables that will affect on the response. You do or you expose the subjects to the conditions you already know. Of course, these conditions are independent variables. So you already know them. But for the observational study, you don't know them. You just observe. So if there is any other variables hidden that we cannot observe, of course, will affect on the results in this. Something about the observational study is what sometimes you will not be able to find the association, okay? And also, if you find the association, this association doesn't imply the causation, okay? And if you remember last time, we talked about the relation between association and the causation. You may have association, but you don't have a causation because the cause here is not scientifically proven, okay? Like what? For example, it's already proven that the type of gas affect on the number of miles you can do, right? It's proven. So if you put 82, it's not like 85, it's not like 92 or 95, right? Of course, when you have higher grades, this will give you more mileage. Okay, it's scientifically proven. So here we have a causation. But for the same example, it's not scientifically proven that you will drive your car until finish all the tank. So you can observe what the number of miles you make based on the grade, right? It's not scientifically proven. So we have association, yes. If you drive a lot, okay, with the type of grades of gas, this is of course will have here a variable number of miles, okay. But of course, this some people will drive a lot, the others are not, okay. So it's not scientifically proven in this case, but it's already scientifically proven that the type of grades affect on the number of miles. So this is the causation. But the number or the time you drive, and the number of miles based on the gas grades, it's not scientifically proven. But some people drive for many hours or a lot of hours, and that some people are not. So it's not scientifically proven. So we have association, but we don't have a causation in this. Of course, when we have experimental design, that means you can study the explanatory variable because you already know them, and the effect of these variables on the dependent variable or the response variable when we have experimental design. But for the observational design, it's hard to do something like that. So something also it's important to know which type of study you should use or possible to conduct. Okay, so if experiments are preferable, why ever conduct observational study? Why we have this type? Okay, of course sometimes the experimental study is hard to conduct. Okay, for example, it's difficult in practice to make sure that the subject behave as told. How can you monitor them to ensure that they adhere to their treatment assignments over the 50-year experimental period? So of course, this is something impossible to do, right? The researcher maybe die before he can done from his experiment, right? So this is sometimes something impossible to do. But the observational study in this case will be better or preferable, as you can see here, because the effect of the time in this case will be lower than you do the experimental design. Sometimes you can get the data it's already collected, okay, from the internet in most cases, or from the agencies. You can collect the data because they already do that for you. But the more important thing is to do what? Is to make sure that you collect your data from confident agency or confident website. Not any website gives you the correct data so you can use and analyze. You already have here some, can say, websites that you can use to bring data, and these data are very, very good. The census and the other sample surveys. Okay, of course, the sample survey, that means you select uh, a sample from the population and you start to collect the data from them by asking them questions, questionnaire or something like that. Okay, uh, we consider the sample survey a type of non-experimental study. Non-experimental study. Make sure that you know this part. The census attempts to, what is the census? Of course, the census, you already know the census, like the US census. It's happening every 10 years, okay? So we try to count the number of people in the population and to measure certain characteristics about them, like the number of male, number of females, the percentage of male, the percentage of female, the income, the number of children, kids, number of houses, the number of cars for each family, okay, something like this. So this is the census. So other than counting the people size, as I said to you, for the US census, also we, as you can see here, we need something very important about the constitution, okay, which is the number of seats in the House of Representatives be appointed to states based on their portion of population measured by the census. Okay, as you can see, the number of seats, of course, increased if the people what increased as well. Census data are used in drawing of boundaries for the electoral districts, and also the census data are used to determine the distribution of federal dollars to states and the local communities. Sample frame and the sampling design. What is the sampling frame? As you can see, it's the list of all subjects in the population, okay, from which the sample will be taken. Of course, and for some populations, you don't have this list, okay? Keep this in your mind. So the sampling frame lists the entire population of interest. In practice, is usually hard to identify as a city. Once you have a sample frame, you need to specify a method for selecting a subject from this population. Why? Because based on the type of the population, you will determine the type of the sampling method. which one of them I can use to select my sample from the population or the sampling design. The simplest type of sampling is simple random sampling. We call it SRS. Okay, simple random. Sometimes we call random sampling direct or random sample. Okay, as you can see here, the subjects from the population has the same chance to be selected in the sample. Okay, so this is the random sample. Like what? If I have a class of 100 students, I can select 10 students randomly like this. I already have the list, right? But I will select my sample from this list, just 10 people randomly, or 10 students. This is the simple random sample. So as you can see in this graph, you have to know, identify your sampling frame. So this is the population. As you can see here, some of them are blue, some of them are red, some of them are green. This population is not homogeneous, right? It's different. We have blue, we have red, we have green. So you can divide this population into different groups. We call them demographics of interest. Okay? And from each group, you will take a simple random sample. This makes sense. Why? Because we need your sample what represent what the entire population. Don't take just a simple random sample from anywhere, because you can go to the take more people or red people or more red or more green people. This is of course the effect on the sample. It's not representing the population quite well. But if you started to take a sample based on the size of each group, this will represent the sample in this case represent your population. And as you can see in this example, you have 3 blue, 6 red, 3 green. So if you need a sample of 4, you need to take here the percentage is what, as you can see here, what is the percentage here? A half, 1/4, 1/4, right? So if you need 4, you will take from here just 1, and from here 2, and from here 1. So the total now is what? Is 4. So this sample now represents your population. Okay? Do you see what I mean here? So when you take a simple random sample from each group we have here, we call it the sample design, the sampling design, the sampling design. Okay? Actually, we will talk about this design after a while. We call it stratified sampling. Stratified sampling. Okay? But as I said to you, the simplest method for sampling is what? The simple random sampling. Just to take a sample from the group. Of course, we have a limitation here, or a condition. What is this condition? To take a simple random sample from the population, all subjects in this population must be homogeneous, close to each other, right? In this case. Or no differences between them, a lot of difference between them. Okay, so this is of course the way of selecting the simple random sample. So you should have the sampling frame, which means you know the number of subjects in this population, and of course you generate random numbers. Usually we use computer to generate these numbers, and then start to select them from the list you have. As you can see here, the computer can generate numbers, and based on these numbers, you can select the subjects from the population. If you have a survey, how you can collect the data from the survey? After you determine your population, okay, you determine the sample. Okay, from this sample, you will collect the data. But by a survey, how you can make personal interview or telephone interview, or you can send an email for the people, and but this type is not quite represent the population actually, or self-administrated questionnaire. So these are the type of survey you can do to collect the data for the sample surveys. Unfortunately, we have some problem with this type of method or collecting the data or sampling. The first thing is what? The bias. The bias means that your sample doesn't represent the population quite well. So we call it a bias. And also the undercoverage. The undercoverage means you don't take your subject from the entire population. You just missed some groups or a part of play or a place or something like that. So you have this problem with the sample surveys as you can see. Of course, you have the summary for sample surveys. How you can have you have here the sampling bias, as I said to you. That means uh, it's not random. Non-response bias. What that means? That means you already sent the survey, but some people didn't reply. So we call it non-response bias. Response bias. You already sent the survey, but the people are lying when they answer on the question. So in this case, you have a response bias, as you can see. So these are the three bias in sampling survey. So because of that, I said to you, the sampling survey is not good enough to use, but sometimes we have to do it because there is no other way we can conduct uh, the study. You have to collect the data by this way. Okay, so there is some methods. Of course, it's not we cannot talk about it here in this class. So how to reduce these three biases. Sometimes you take a sample like what? Okay, I will do this study, so I will take in this, my sample will be my family, my relatives, my friends. Why? Because it's so easy to reach them, right? When you have something like that, we call it convenience samples. Of course, it's not good type of sample, actually. Okay. Sometimes it's good. Like what? If you would like to ask the people about their satisfaction for a product or something. So you can go to the mall or Walmart or whatever the store and ask the people who come and they take this product. Is it good for you or not? Do you like it or not? So this also is what a convenience sum. But sometimes it's good because it's give you indication about the satisfaction from this product. Okay. But if you wanted to do inferential statistics, you wanted to generalize the result to the entire population, no, don't do that. This type of samples will not serve this type of research actually to do inferential statistics. But it gives you some indications or some um, information about the population who just like this product. As I said, the convenience sample, just it's easy to access. So in this building, there is this lady, ask one just passing by her house, what do you think or do you support this penalty? Okay, so it's easy to reach the subjects as you can see. Volunteer sample. What is the volunteer sample? Volunteer sample means if I would like to do a study or a research and asking you who will be a volunteer, so I will take them. What about the others? Maybe someone is shy to participate. So again, this is not a good way for sampling as well. As you can see here, volunteers don't tend to represent uh, the entire population as you can see. So in this for this graph, as you can see here, some people are so exciting pick me, I will be here, but the others are shy. Okay, so it's not a good sampling method that represents the entire population. Sometimes, and you will you will hear this a lot in the statistics course. Okay, a large sample is very important because it will reduce the bias. No, or it's not always the solution to reduce the bias to increase the sample size. Okay, this is not the case. As you can see here, for example, many internet surveys have thousands of respondents. But what? Because they volunteers. Sometimes you receive an email, ask you about something, you refuse to answer, right? Right? So when you agree to answer, that means you become a volunteer in this research. Okay. So to solve this problem, it's better to have a simple random sample of 100 people than you will have thousands of people from the internet in this case. We have here some definitions for the experimental design. Like what? What is the experimental units? Of course, the experimental units will be the subjects. Maybe these subjects are what people, animals, lands, anything, houses, cars, okay, anything. Okay, so these are the experimental units. Treatments, and as I said to you before, treatments means these are the conditions or the factors that the researcher will expose the subject to them. Okay, and we call them treatments, or we can say these are the explanatory variables. The explanatory variable defined a group to be compared with respect to values on the response variable. So we have independent variable, explanatory variable. This explanatory variable effect on the response variable. The response variable is the outcome of the effect of what of the treatment or the explanatory variable. So usually in the experiments, as you can see here, we impose these treatments on the experiment units in order to observe their responses. The goal, of course, is what? To investigate the association, okay? Or how the treatment affect the response. The advantages of the experimental study, as I said to you, over the non-experimental study, like the observational study, for example, that it's give you a strong evidence of causation because it's scientifically proven. You prove this association. The elements of good experiment are what? First, control comparison group. Okay, allows the researcher to analyze the effectiveness of the primary treatments. Randomization. When we do the randomization, as I said to you, we randomize our subject. That means we select them by a simple random sample. This, of course, reduce the bias in this case. Blinding the study. What that means? That means that the subject is, of course, as I said to you, for example, suppose we have two groups. One of them will take the treatment, and the other one will take fake treatments. Okay. Of course, you will assign people to these two groups. These people doesn't know if they have the real treatment or the fake treatment. This is what we mean by blinding the study. Okay, so the subject will not know if he will receive the real treatment or the fake treatment in this case. So for the control comparison group, as I said to you, we have a fake treatment and real treatment. So the control group will receive the real treatment. We call them the control. So the group who take that real treatment, we call them the control group. And the other group that will take fake treatment, there is a treatment, but it's a fake. What do we mean by fake? That means, for example, the pill doesn't have an active substance to treat, for example, a disease or something like that. Okay, so we call it dummy treatments or fake treatments. They will take a pill, but it's not a treatment. It's a fake treatment, as I said. What is the effect of placebo? Placebo means fake treatment, or the group who will take the fake treatment. Okay? People who take a placebo tend to respond better than those who receive nothing. So when I see something, I have two groups, and I will still tell the subject, you will be in the group that will not take anything. Of course, this will affect on him, right? He will feel, why I don't take the treatment like the other group. So this will affect on him, right? But if I will give him a treatment, but this treatment is fake, he will be happy. Like the others also will be happy. They will take the treatment, but they don't know it's fake or not. So as you can see, perhaps for psychological reasons, they respond better than nothing. In some experiments, a control group may be receive an existing treatment rather than a placebo. This just happens sometimes. As I said, randomization is very important in the experimental design. Why? Because it's reduce the bias. Okay, as you can see here, to eliminate bias that may result if assign the subjects, to balance the groups on variable that you know affect the response, that to balance the groups on logic variables that may be unknown to you. So the randomization process here will eliminate all or balance all these problems, all will treat these problems. As I said to you, blinding the study, that means the subject will not know if I will take the fake treatment or the real treatment. So as you can see here, it's important that the treatment group be treated as equal as possible. Ideally, the subjects are blind to the treatment to which they are assigned, and you can do double blind. How? When neither the subject nor those having contact with the subject know the treatment assignment. The study is called double blind in this case. Of course, this would be better than just you have one blind. Of course, after you do the experiment and you find the association between the treatment and the response variable, in this case, you should generalize your results or findings to the entire population. You usually see something like that when they discover a new treatment for something. We hope we can find a vaccine for the COVID-19. Okay, so of course they will start to make we take a sample from the people to see if the effectiveness of the COVID-19 immunization. Okay, and then if it's good, they will give it to the entire people. If it's bad, of course they will return to the lab and they see what is going on. They try to improve it, or they try to find something else to help to recover this problem in this case. And then we will talk about the ways of conducting experimental and non-experimental studies or observational studies. Okay, this part is very, very important because, as I said to you, according to the type of the population, you will select the sampling method. Like what? The simple random sample. You can use it if all the subjects in the population are what? Are close to each other. They are homogeneous. But if they are different, and we can put them in different groups, in this case we have different type of sampling. Okay, like what? We have cluster random sampling and stratified random sampling. We will talk about that. So the cluster random sample is what? What is the steps of obtaining a sample by this method? First, you have to divide the population into a large number of clusters, such as city blocks. So suppose we need to study something in North Carolina, so we can divide North Carolina based on the counties. You have different counties, right? Okay, this is the first thing. And then take simple random sample from what? From the counties, from these clusters. And started to use all subjects in these counties. So for example, we randomly selected 4 counties from North Carolina state. So you will use all people in these 4 counties to as a sample and to start your study. This is an example. As you can see here, we have the election percentage in the Carson County. We have different zip codes. We put this a list for these zip codes and started to select the 3 counties randomly, and we will use all subjects in these 3 counties as a sample in this. We have advantages and disadvantages for this type of sampling. First of all, we'll talk about the advantages. So it's we prefer the cluster sample if reliable sampling frame is not available. Sometimes you don't have a sampling frame. You cannot determine the population quite well. So you can use the cluster sampling in this case. But the cost of the selecting of the simple random sample is excessive a little bit. The disadvantages, we usually require a large sample size. With cluster sampling for the same level of precision, selecting a small number of clusters might result in a sample that is more homogeneous than the population. So the differences will be close than the population. What about the stratified random sample? Also, you can divide the population into groups. These groups, we call them strata. Okay? But this time, you will take from each strata a simple random sample. So what is the difference now between cluster and stratified sampling? In the cluster sampling, you divide the population into, I will say, groups, okay? And you will select a random sample from the groups. So the groups is like what subjects you will select. But for the stratified sampling, you divide the population and you will take a simple random sample from each group. This is the difference between cluster and stratified sampling. Like here, suppose the population we have consisted of the male and the females. Okay, and they are equal. 50% are female, 50% are male. Okay, so you will take a simple random sample from each group. Here you have 2 females and 2 males, as you can see. So the advantage of the stratified sampling is you include in your sample enough subjects from each group. The disadvantage is that you must have the sampling frame here, and also you know the stratum into which each subject belongs. Like male and the females, I know I have 2 females from this group and 2 males from this group. Okay, so you have to know from where you select these subjects, which group or which stratum you have them. So in this graph, you have here the 3 types of sampling, as you can see. The simple random sample, as you can see, you have here dots, stars, and the X's. We consider here that all these items are similar to each other, so you can take simple random sample like this. But for the stratified sampling, you have to have frame for your population. You divide the population into groups, and you will take a simple random sample from each group. This is stratified. But for cluster sampling, you don't need to have a frame for the population, but you can divide the population, okay, into clusters or groups, and you will take 2 or 3 or 4 groups as a sample, and you will use all subjects from these groups in your study. So these are the differences between 3 types of sampling. As you can see here, also in this table, you will have the descriptions and the advantages for each one of them. Last thing, I think this is the last thing. Yeah. Sometimes you collect the data from the past. So in this case, we call it a retrospective study. Retrospective study. Okay, and sometimes you collect the data into the future. Okay, so in this case, you will have a prospective study in this case. Okay, so based on the data you collect from or the time you collect the data from the past or from or into the future, you have of course these two type of studies. So if you have here, for example, the case control study is a retrospective observational study in which subjects who have a response outcome of interest, the cases, and the subjects who have the other response outcome are compared on explanatory variable. This is a popular design for medical studies in which it is not practical or ethical to perform an experiment. We can't randomly assign subjects into a smoking group and a non-smoking group. This would involve asking some subject to start smoking, and of course, this is not something ethnic, as you can see here. Okay, this is an example for case control study. We have here the response outcome is lung cancer and smoking. Here we have the case have lung cancer and the control didn't have lung cancer. So we have two groups as you can see here. The two groups were compared on the explanatory variable, a smoker or non-smoker, as you can see in this table, the lung cancer cases and the control, smoker, yes or no, and we have the number of people in each group, as you can see. So the retrospective aspects refer to studying whether the subject has been smokers in the past. As you can see here, this table show that the probability of the smoker here for the cases that have lung cancer is 97%, and for the controls, which means these people doesn't have a lung cancer, it's 96%, as you can see. So this two, again, these 2%, how we can calculate them? You divide what? This number by the total. So you have 97%. And for the controls means that these people doesn't have lung cancer, okay, but they smoking, okay. So you divide this number by the total here, so you have 92%. Type of non-experimental studies. As I said to you, we have this summary. We have three of them. We have the retrospective study looking into the past, the prospective study, which means we have groups or of the people and we observe them to the future, maybe 10 years, 10 months, whatever the time in the future, okay? And the sample survey takes, of course, something called the cross-section. Cross-section means you have a specific, you determine a specific period, and from this cross-section, you select your data. As you can see, cross-section of a population at the current time. Sample survey are sometimes called cross-sectional study. Okay, so this is the opposite of the time series. If you remember, the time series means here multiple periods. But the cross-section is the opposite of the time series. That means you, in the current time, which means 1 month or a specific year or a specific day, you start to collect your data by a survey. So this, we call it cross-section data, as you can see. So this is the end of the chapter number 4. As you can see, it's just talking about the type of studies, the type of the sampling methods. And to summarize this chapter, the more important thing to know is 3 things. The difference between the experimental design and observational design. Second thing, you have 3 sampling methods: simple random sample, stratified sampling, and cluster sampling. The last thing, sampling bias, non-response bias, and response bias. So these are three types of bias, and they all are related to the sampling survey. The sampling survey. And when I say sampling surveys means, or you collect the data by interview or by the phone, by asking a question, okay, to the subject. So of course you will have these three types of bias, and yeah, we have some ways to reduce this bias, but as I said, some of them is the randomness. So these are the three things are important in this chapter. I know we have here a lot of definitions, but if you read them, you will find it's easy. It's not hard, and they will let you distinguish between the type of sampling, because in most cases you will have a scenario, okay, like your case studies, and the question is, there is how did the researcher collected this data, and you will let us know, is it a simple random sampling or stratified or cluster.